Great. My name's Kwame. I am well, Tim actually gave me a new title. I'm a researcher, but I'm just kind of just a hacker. I go around. I love finding new tech. I got involved with Ethereum in 2014 at the Toronto Bitcoin Expo, and I kind of stuck with Ethereum, just kind of hacking around in the early stages. My background is actually in games. I worked at a company called Jammed Mobile in Montreal. They became EA Mobile, and I worked on a game called Bejeweled. And if you've heard of mastery game mechanics, that's kind of my background, which really plays well into blockchain-based games. Simultaneous action selection, which is kind of my background. And right now, I work with Reach. That's a dApp programming language. I don't know if anybody's heard of it, but there's been some press in the space. And it's a blockchain agnostic framework. Right now, it does play really well with the Ethereum world. And that's what I'm going to basically showcase. So I'm just going to run through some code and kind of give you an idea of how dApps are built in Reach. And hopefully, it'll give you an idea, or maybe just give you some an opportunity to look at something different other than Solidity. Not saying that Solidity is bad. I'm just saying if you want an alternative, there's other ones out there. Okay, so I'm going to share my screen and make sure. And hopefully you guys see an Visual Studio Code with a host. Okay, so I'm just going to really just go through the code and kind of demonstrate how dApp's actually built out. So this is our index.rsh. This is your Reach file. And you can just see like an import directive in the top here. Now you'll see that we have this all players. This is just kind of like an object that we can associate with a player one and player two. Now player one and player two in Reach are defined as participants in consensus, really. So this is kind of how a participant would be built out. So you can see we have a player one. This will have a wager of type unsigned int, and it's being composed of this general interface. So we can see that the player two is going to accept a wager. It's going to be a function. We see we have a tuple, which is just an unsigned int at this point, and it's going to return a bool. And you'll know in blockchain games that doing things in coin flips and yes and no are just really efficient. Okay, so here we have like, which would be considered like, our main entry point. You can see we have our reach.app, and then we define the participants, which their string name, which we bind in our front end. And you'll see that we have an object for player one, and then we have the player two with its own object. Now, this is where Reach becomes really simple if you think of it in terms of, Alice does this, and then Bob does that. So here we have our a.only, and this is called a local step, right? A local consensus step, where we declassify. And oh, good. So we have this is actually the IDE for Reach, and I'm doing some edits in it. And you can see here we have some post issues. So we have inside the editor, which it'll define what an interact object is. So as you're kind of coding through, you're getting a lot of hints as you work through your code. So what we're basically defining here is that Alice is going to set a wager. We're going to declassify this. We're going to set it into this variable named const. And then when we publish this, when we send this out to the blockchain, what do we want to do? We want to publish a wager, and then we'll pay a transaction for this to be deployed on the blockchain. We access this function called commit, which basically commits this information to the chain. So if you're designing kind of like maybe like a construct of a ERC20, you could really just do it with defining an interface, Alice, who would deploy it and then just deploy it out. So here we have Bob, and Bob.only means that this is something only Bob can do, and whatever's inside it is its local step. So here we use the declassify. Declassify just means that this private information will be opened up so that it can be published to the network on Bob's behalf. We interact with his function, and then we pass in the wager that Alice set. That's kind of how this works. And then Bob is going to pay the wager. And here we just have a variable for the outcome. And this might be different for people who've never used this. It's called a loop invariant. And a loop invariant is basically you're defining what the outcome of your loop is going to be before it happens. So while you're going through this loop, and here we're, this is a game of Morra. If anybody's played the game of Morra, rock, paper, scissors, diplomacy, the same type of game where you have modulo arithmetic for say 3 outcomes, right? And you have like true and false, you have something in the middle. You don't remember the one that's in the middle, you just kind of do the 2 and you kind of do modulo arithmetic to determine a winner of a certain outcome. Because it doesn't matter if it's a million of coin flips, it's still going to be true and false. So that's kind of how that's defined. So here in this outcome, we have the finger and the prediction, and these are private local steps. So anything that's defined with an underscore is a private local step. You'll notice here that when we do our publish, we're kind of declassifying which information. And then this salt here is just a standard library function that does randomization for you, salts your information. We kind of continue down, we go, it's a lot of the same steps. That's the one thing that's cool about Reach, is that if you understand the concept of gaining information, declassifying it, publishing it to the network, it's really just similar steps that you do. It's like Alice does this, publish it to network, Bob receives that, does something with it, publish it to the network. And every time that we're going through and we're committing and we have our publish and pays, that's where our transactions are happening. So if you're looking at as it and developing a dApp, you're not just building a contract and then going, okay, well, let's put some UI to it. You're building up, if that makes sense. Like you start off with a contract and a front end with little complexity, and then you build it up in parallel as it scales up. Okay, so what I'm going to do here, as you kind of go through, you can see here that at the last part we have this assertion. Assertions are how we do testing in Reach. So when you write an assert, it creates a theorem and it uses a verification engine to determine if all these simulations will result in true. And if there's any money left on the table or anything left, it will fail. It won't even run. So there's no opportunity to have money left on the table when you write in Reach. It's really safe. So you can see here that we have this assert balance, right, or this wager, and it's the same at the top. So we're making sure that everything that's happening in this game loop, because this is actually a game, in this game loop, results in making sure that in this coin flip, if someone puts out a wager and they accept it, there can't be anything left on the table. Here we just have some regular programming for a ternary operator. And as I said before, we're really based on this whole 0-1 in this game world. If you're building games in the blockchain, you're dealing with that kind of truth and false. And then here we have our transfer function. So this is basically for Alice, right? Times the wager to Alice, or we transfer the wager of 0-1, which would be Bob, to Bob. And then here we have the interact. So each interact is where we run that display winner outcome. So we get the outcome and then we display who the winner is. And that's basically it. That is all you need for a game of Morra. Now I'm gonna go in here and in the build, and if you guys can you guys see the build information here? It should be the same screen. I'm in an index main.mjs. This is the back end. So this is what is actually compiled from your Reach program. So you can see here, this is a lot of what we're used to, right? The one thing you'll notice is that I am scrolling a lot, right? And this is what this is the generated Solidity code from a Reach program. So if you look at the simple complexity, well, it's simple because I've been writing it more, but if you can see the simplicity of this, anyone can really generalize what is happening in this program, where if you're in a Solidity program, you could probably get lost pretty quickly. A lot of complexity. Another thing that is generated when we actually generate our file is a little front end. So I'm just going to, sorry, I don't know if I'm breaking up. Here is just going to run out a game of Morra.
Maybe you could try
here,
and turning off your camera, because you have been breaking up just now a little bit.
Yeah. Okay.
Thank you.
All right. Hopefully that's better.
It's
okay, perfect. Thanks. Oh, perfect. Okay, so in here we have our index.mjs, and this is just the a front end file. And when you run, let me just do this here. I'm just going to go. If I just do this, it should just bring it up. All right. So inside we have all these different options that we have, but the main one that you get when you start working with Reach, it got removed. Oh, there it is. No, sorry. This reach init. This reach init sets up your first, index.rsh file and the front end for it, which is really cool. Because when you start building this up, as soon as you get to the point where you want to start putting in UI, as a developer, I'm not the greatest UI guy, but I want to have a console-based application where I can go through these processes. So what I'm going to do here is I'm going to clear this out, and I'm going to run this game of Morra. So I'm going to compile it. And you know what? I really should have tested this because I added this postage so you can create GIST in the IDE, but
Lou, we could see your screen running, but we can't.
Oh, okay.
Here you go.
Am I still there?
Yes, now you are.
Okay, I do think my internet went out, and I apologize, guys.
No worries.
So all good.
Okay, so you're going to see here that we have in our front end, it's going to ask for our player one, and I'll just say yes. And I'll create an account. And not. And yes. And deploy the contract. And I'm going to say, yes, I want to deploy the contract. And I can copy this in. And in a perfect world, you'd want to use a relay or even like a hash lock, but I'll just say no. And I'll just deploy the contact information. Okay, and I'll just say 500 and accept the wager, be yes. And in this game of Morra, I'll just say 2, what's the prediction? 4. And I'll kind of just do the same thing just to show. Okay, so now the game is kind of like in its game loop now. And I'll just say 2, 4, 3. And I'll just say 2, 4. And you can see that the player 2 won in this game and the transfer of funds went through. And in the next level, you would actually have, I have another project that's called Scaffold Reach UI, which actually has where you create an NFT and it has like the React front end for it. But in the base construct of how Reach works, you start with this index.rsh. You have this really simple index.mjs file, and then you scale up your contract and your UI in succession, which I think is really cool. And if you have a lot of other toolings and you've been in the space for a long time, we've gotten used to Truffle and we've gotten used to Hard Hat. And but if you're really new, this is one of the biggest pain points, is just kind of building a simple dApp and having it work. And this has everything for you. And if you get the IDE, the Reach IDE, and you can start playing around with Reach. And I'll throw in the link to the doc site that runs you through a tutorial of actually creating rock, paper, scissors. And yeah, so I mean, hope you guys think it's interesting. Take a peek. That's all I got.
That's amazing, Kwame. Thank you. I always love like coding sessions in these talks, because I'm not a coder myself, and I'm not a technical person myself at all. So it's just nice to dig into the code, and I think everyone else probably thinks the same way too, based on the response. We got one question here from Phil. Phil, do you want to just ask directly yourself?
Yeah, sure. Just wanted to know what are the limitation of reach? Because you said that everyone is still using Solidity, and it was really cool demo to see all the code produced versus what you type. It looks like the future. What are the limitations right now that makes that people don't take the leap yet? Maybe.
Well, I mean, reach is really new. First of all, I think it might need some support from maybe like a consensus or something like that that says, "Yay, you know what? This is actually an alternative to it." And I'm not trying to say that we should stop using Solidity, because there's just some stuff that has to be done in Solidity. But a lot of this higher level stuff where, transferring of funds, like, do we really need to write our own transfer, functions or balance of functions? Like, this is kind of boilerplate stuff. And we do get this from consensus. But I guess what I'm getting at is we learn how to write the code, but most of the time we get to this point in Solidity where all this stuff is just boilerplate. And a lot of the mistakes are just happening from people copying and pasting other stuff, right? So an integrated development environment for a new person to dApp development is perfect, because this is actually creating a dApp. It's not just building a smart contract, right? Where in Solidity or something else, you just build smart contracts. This is actually building a dApp, right? And my experience is more of like front end HTML5 games, that kind of stuff. So now with a lot of the L2 scaling solutions, like coming back into this is like, well, I want to build games, but that wasn't really the case. So not a lot of people really thought about building dApps. They just thought about building contracts and simple interfaces for it. But now we're building games, right? We're transferring, real world assets. So it's we need a framework. And Leon did some really cool stuff with the Unity, right? Like, that's the future, right? No one's
might look silly, but where do you draw the line between a smart contract and a dApp? That's unclear for me.
Wow, that's really good. I mean, a smart contract can basically run on its own. Like, if you think of an ERC20 for just building a token, you don't need a dApp for a token. You just write a smart contract. You use Remix, pop it up. You inject your Web3. You hit whatever chain you want to hit, or version of ETH or whatever you have in your MetaMask, right? With this solution, you're thinking about, well, how is the user going to interface with this thing as you're building it out? So now when you build your UI, like, my biggest problem in dApp development is that I write a contract and then I'm thinking about the UI and I'm like, oh geez, right?
Oh, I see.
Yeah, like,
yeah, thank you. Makes sense.
10%, like 90% of your time is going to be building a UI, right? And it's the UI that takes the longest in this space. Well, I should speak personally. The front end takes the longest. Like, 10% of my time is writing a contract, and 90% of my time is writing the UI. So if I can build it up in a text-based way, and then it's like, okay, you have like this, the way that it was defined here. If you gave that to a really slick front end developer, they would have everything they need, right? They're just like, all right, cool. Where this console part is, and where this player is, I can write the code to logically work myself around that. If you just gave them a big, huge smart contract, they'd be like, what? Right? So, I mean, I guess that's the difference. I'm thinking of how you build up dApps from maybe a full stack, blockchain developer, if there's such a thing.
Cool. And Jimmy, did you want to unmute yourself and ask your question?
Yeah, I mean, I think Leon answered it. Just, it was about you made a comment about it being blockchain agnostic, and I was wondering if you could expand on that.
Yeah, so it's Reach is blockchain agnostic. It supports right now, of course, all the EVMs, right out of the box. No changing anything there. This technology was originally spearheaded and funded by a blockchain called Algorand. They are like a zero knowledge type of blockchain, and Vitalik was hanging out them at Bitcoin Miami. So obviously they're probably talking, as we know that Vitalik loves his zero knowledge stuff. So it was originally developed by them, and it works really well with Ethereum. So I saw the project, and right now they have they're in talks to do stuff with Cosmos. There's some other talks. I think ADA, the Cardano project, and yeah. So as these parachains start going out and these opcodes start being released, then we can start working around and doing it. But as I said before, I don't work for Reach. I stumbled on the technology by buying some algo. And I was like, wow, this is pretty cool. It makes it really easy for me to build a dApp. So I'm all for it. And that was it.
Awesome.
Nice.
Well, thank you. Super interesting stuff.
Mark, your hands are raised.
Yeah, thanks, Kwame. That's really interesting. So I had a question. Since the reach is being transpiled or compiled to Solidity, is there any question about the efficiency of the Solidity code?
That's a really good question, and Jay would probably be, better to answer that question at the compiler level. But I do know that there is optimized, like gas optimizations that the Reach compiler can do, right?
Okay.
So a lot of developers know that if we write more efficient code, that is a lot more efficient on the EVM. But who really wants to go and do the thought of it? Like if we can have the compiler really optimizing our code, like a good LLVM, right?
Sure.
Like everybody writes better code now because a group of people actually put effort into developers wanting efficient code to create LLVM. So there's kind of the same thing here, but like it's a really good question, and I'm going off into hyperbole. But the compiler does do some optimizations, but I can't say for sure that it would be more efficient to write in Reach because of that transpilation. That there has to be some friction, but the optimization should balance that.
Okay, thank you.
Thanks.
Cool. And one more question in the chat. Does that mean you're looking for front end devs?
Am I looking for front end devs?
I think so. Or if JZA, if you want to ask a question.
If there's people that like want to help out, I am trying to put some stuff together and look for. I actually want to interface Reach's standard library with pure Web3. So yeah, I'm kind of putting some stuff together, and if there's people out there that want to help build blockchain games, that's my background, and yeah, I'd love to cross pollinate and definitely if you want to pass me your information, I'll definitely link up with you for sure. That'd be great. Appreciate it then.
Yeah, you guys can always use the chat. But I think that's it for all the questions. Kwame, thank you for stopping by and giving us your talk. That was great. I love honestly watching people dig into the code.